we're going to look a little closer at what the electrons are doing around, the valence electrons are doing around these, what are they, 5 elements. So on the next page, you're going to see actually some dots that represent valence electrons. Just to make sure we're all on the same page, my question to you is, how many valence electrons are there around a nitrogen atom? Hopefully you said 5, because it's a 5A element. So we have these electron dot formulas, and I kind of have a little bit different word what to call these. But if we pick on nitrogen, you guys told me there are 5 valence electrons around a nitrogen atom. So what this Lewis dot formula does is it has basically the letter N represents the nucleus. So we have the protons there, we have the neutrons, and then we have the non-valence electrons. Non-valence electrons. So that's what the N represents. And so then those 5 valence electrons are represented by dots here. So we have dot, 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 dot. Of course, that's 5 electrons. Now, do you guys remember that I talked about what sort of electron configuration do atoms want to get? Well, they basically want to get 8 electrons in their outside. Remember, when you're adding electrons or giving off electrons, you're not doing anything with the protons and the neutrons in the nucleus. So anyway, that's kind of what we have going on here. If you look at this, you can almost kind of see, I'll pick on carbon here. Carbon is a 4A element, so you can kind of see the 4 valence electrons here. If I was going to saddle up in these empty spaces, okay, notice where those arrows are. If I put one more electron there, I have 4 arrows, that's 4 electrons. I already have 4 electrons, so 4 plus 4 is 8, okay? So carbon, if it picked up 8 electrons, if it picked up 4 electrons added to the 4 valence electrons that it has, then it has what we call a complete octet, right? So this slide, oh, did I skip a slide? I must have. Must not have been too important. Okay, so going on to this slide. So helium is atomic number 2. There's the 2 electrons around a neutral helium atom. And actually helium is at the top of our group 8A elements. I know it doesn't have 8 valence electrons, but it actually is a rare gas. It's a wonderful configuration. It is a rare gas, but it doesn't have an octet. Okay. Oh, there it is. I guess I had it out of order. The term Lewis, the term Lewis electron dot that you saw a minute ago, actually, I reserve that only for ions that have only one atom. I misspelled that. Should say monoatomic species. I like to reserve the word Lewis structure then, and we're going to be doing some of this in lab, for those ions that have more than one atom, polyatomic ions. Okay, so just kind of a matter of semantics. All right, so sodium's a 1A metal, and remember metals lose electrons, so here's the 1 valence electron around a sodium atom. Okay. Now, we actually showed in the case when it forms sodium chloride, table salt, we showed that 1 electron going away. And in the previous slides, I kind of showed you when that 1 electron goes away, it becomes a +1 charge. And now actually, instead of having, now it actually has 10 electrons. And so it is like the element neon. Do you remember I said that? Okay, it is actually like the element neon. So here we have a sodium +1 cation. This is the sodium +1 cation with what we call its new valence electrons. And its new valence electrons actually are the 2s2 2p6, right? So, of course, 2 plus 6, and we're going to be kind of looking at this later momentarily in this part. 2 plus 6 is 8. So this actually is what the sodium +1 cation looks like. Let's do a similar thing. Instead of picking on chlorine, let's pick on the halogen above it. Let's click on fluorine. This is what the 7 valence electrons around a fluorine atom. It's 7A. Now, the nonmetals pick up electrons, so here we go. Let's let it pick up 1 electron and get a complete octet. Okay, there is what the fluorine anion looks like. Okay, so does this make sense? Basically, what you saw was an electron park in there. It gets a complete. I got 8. You get 8 electrons. Gets a complete set of 8. Now, actually, it has, for its electrons anyway, not its nucleus, but its electrons are like the electrons around neon. And neon is a rare gas, and all atoms want to get a rare gas configuration. See how that works? All right, one more kind of similar. Let's go ahead and pick on another nonmetal. Sulfur is 6A element, so you can see the 6 valence electrons around a sulfur atom. Notice that it needs to get your cars running. It needs to park. It needs to park 2 places in order to get a complete octet. And that's exactly what sulfur will do, is it will pick up 2 electrons to get its complete octet. Now, since it picked up 2 electrons, can you see that the charge now is a -2, right? And when it did that, if you look at where sulfur is in the periodic table, it picked up 2 electrons, and now not its nucleus, but now its electrons are the same as argon. Its nucleus still has the same number of protons in it, so it's a sulfur something, but now its electrons match that of argon. Alrighty, so we're bumping up against an assignment slide. So go ahead and take a look at what you can do with this. Now, I'm going to be looking for this homework, but don't sweat it too much, okay? Let me know if you have any questions.